So we had a question of 3. Was that correct? So we've got, and remember this is one of the tools in your arsenal. And Bobby made a really good point the other day too, and I'll just... What was that point you made, Bobby? So when he was doing, let's pop that one there. It was 2b, wasn't it, Bobs? Yeah. So when he was doing 2b, he was saying, can I use my calculator and use that to sort of factorize this and then equate the 2? Now, sure, but remember there could be some questions where they're saying no technology, and they might come up with some, or try to come up with some quartics where you wouldn't get exact answers. So if you got some of these zeros being 1 plus or minus 2i, you could then use sum and product and get your quadratic factor. Does that, you know what I mean? But what they'll try and do is find ones where it wouldn't give you nice, it'll give you all decimals. What happens is your technology is improving beyond some of us, and they go, oh, I didn't realize that it gave you such perfect values. So try and do the equating coefficients. But look, if it doesn't say you can't use your technology, whatever, mix it up. Absolutely. I love that you're thinking from a different point. So awesome. And you'll see that we will come in a moment in one of the later exercises. So you might be looking at the program and going, oh my God, there's so many there. You'll find that there's repeat. So we'll do sum and product again. I think we touched on that earlier, didn't we? And then it comes up again. So you get this repeat little section as we go. All right. So were there any questions from 1 and 2? I'm going to do my thing, hopefully, for only 10 minutes. So if you're feeling you want to ask a question just with me, that's fine. All right. So question 3, show that this can be factorized into 2 real quadratic factors. So we got an idea. It's probably very similar. Oops, why didn't that go? I would say it's very similar to this one. Yeah? So we would say z to the 4 plus 64, because it can be factorized into this and this, what that is saying is, can we write that Oui. And so it's really 2 questions in one. So you'll do this, you'll solve it just like you did with question 2, and you'll get a value for A and B. And then you'll try and do it for this one, but you'll find that it doesn't make sense for your values for A and B. So it might be that you end up with A being a square root of a negative number, or it's just not possible. Hello. I shouldn't have, sorry, hang on. I shouldn't have them in the same color, should I? Whoop. Look at that. Been away from my board for so long. Taking a little bit of time to get back into the groove. Sorry, yes, Mac? Yes, it's as we said. So the question was, do we solve for A and B in both scenarios? Yes, it's a sneaky 2 questions in one. Yeah? And the rest of this sort of exercise, it's going to be reasonably similar. So, find real numbers A and B. Hence, solve this equation. All they're saying is, can you see that this is the same as this? So you put everything on one side, right? So because it's now, you would have solved for A and B, you've got 2 quadratics. Can you then solve that? Yes. If you can't factorize whatever this ends up to be, you can't factorize it, what would you do? Quad formula, of course, we do have technology, so we can go back, but what we're trying to do is just sharpen up some of our basic algebra skills. So, look, mix it up, and I I wouldn't be surprised if you could just pop this all into your calculator again and you would get your zeros. So it's a little bit of a technology is overpassing some of the questions that are in our textbook, but they're trying to make you just stretch and warm up with your algebra. Is that okay? I think that a lot of these are then sort of just practicey. So in a moment, you will be able to go back. If you get stuck, I'll just come and assist. But I just want to recap, and I want everybody here. I could have just done a video for the division, but I like to see your faces and see if you ask questions. So, everybody okay? I don't know if you want to leave a bit of a gap for stuff and then have a heading division. We're going to be doing two things. I'll come back to that page. We're going to be doing two things with division. We want to do long division and we want to do synthetic division. So like we did synthetic multiplication on the first lesson, we have this synthetic division. For it to make sense, I think you have to go back to primary school days and just remind you about your long division with numbers, and then we'll do it with polynomials. So you don't need to write this down unless you really want to. But can I just have a show of hands? Who thinks they never did long division in primary school? I've talked to some students and they've said, oh, my teacher told us, what's the use of long division? You'll never use it. I want to go and talk to those teachers and go, excuse me, we're doing long division with polynomials. Anyway, so much in the curriculum, I don't blame them. So I'd rather you watch and then you can copy down later, but here we go. Normally with long division, when we did it in primary school, we had 2 digits. That's why we went long division rather than the little short shanky one. But here we go. We say, does 5 go into 3? No, it does not. So then we look at the 6. So does 5 go into 36? Yes, it does. It can go in 7 times. And we say, well, 7 times 5 gives us 35. And we pop that there. We put a line underneath and we subtract. We say 36, take 35, we get 1. And this is the fun bit. You then carry down. That's right, you bring down that 1. And now you ask yourself, does 5 go into 11? Oh, it can go in 2 times. And so we multiply. So you multiply 2 by 5 and you get 10 and you subtract. 11 take 10 is 1, and then bring down the 2. Does this make sense for those who have never seen it before? I was such a, I don't want to say square, but I would have my ruler out and these would be parallel, all nice and straight. Loved it. So 5 goes into 12 twice, and then we say 2 times 5, 10. Notice I'm having a bit of fun that every number has a square. Every square has a number. 12 take, don't forget the take. We've got 2. And so this, my friends, is the remainder 2. So I can say 700, I can't say that. I can say that 3,612 divided by 5 gives me an answer of 722, and here's my remainder 2/5 because it's 2 out of 5. You could also, would you also agree with me that this statement would be true, that 3,612 equals 722, so I'm timesing by 5, plus 2, because that is our remainder. Correct? So, and again, I'll save all of this. This now is basically what we've done, but they've just made it look fancy pants, because what we will be dividing is not just numbers. We're going to have a polynomial divided by a linear factor or possibly even a quadratic factor. Yeah? So when you divide it, we get another polynomial. So if you think we've got a cubic and we're dividing it by a linear, what would this have to be? A cubic. So a cubic, yep, divided by something linear, you're going to end up with a quadratic. That would be a quadratic. Obviously, if this was a degree 8 divided by a degree 2, then we'd be a degree 6 and blah. Why? Well, I guess it depends on what your remainder will be, what you're dividing by. So in this case, our remainder here wouldn't be linear, it would be quadratic. 1 over a quadratic, because that's what we're dividing by. Anyway, so these things, and this is our remainder theorem. Again, it sort of just comes out that you go, yeah, it all ties together. So just keep that in mind, but we'll go through. So now let's see if we can do it with actual polynomials. Are we ready? Yeah, baby. Is this saying I'm recording? What's happened? Oh, it is good. Okay. All right. So we might as well take one from the textbook so you can see that I'm not making anything up. Okay, so we'll take that. Oops. Can we see that at the back? All right. So this is probably, if you want to, have a little section, a column or whatever, and going, okay, now we're doing some long division. Unless you go, no, it's all in order. I want my book in order and I haven't finished 2C yet. It's just I know that some people are sort of grooving ahead. Anyway, here we go. For those who are wanting a perfectly neat book, well, you'll get over that soon enough. But when you are doing the division-y thing, just remember you do have to put something at the top. I forget sometimes to leave a bit of room, but you're going to have to put your answers there. So make sure it goes down a little bit so you've got room for your answer. Okay, so we are dividing by x plus 2. And what are we dividing? We are dividing the 2x cubed plus 7x squared plus 10x plus 15. Roy, you might be bored. I think you did this a little different order. You've already done it. You got it under control? So you can do what you want. You don't have to listen. Okay, just you're writing that down. So here we go. We can see very clearly that x does go into x cubed. So you're asking yourself, what do I have to times x by to become 2x cubed? 2x squared. So please notice it's very nice. 3, the 2, the 1, the constant. So you put it above the x squared here. So we're going to say x, you're looking at this bit here, x times 2x squared gives me 2x cubed. Yep. And then what do? How did we get this 35? We actually had to say 7 times 5. So we're going to do exactly the same thing here. We're going to say 2x squared times all of this. 2x squared times x gives me 2x cubed, and 2x squared times 2 gives me 4x squared. You know you've done it right if this first bit cancels out. That's the whole game plan. You want to get that to disappear. So we're going to go subtract. (2x cubed) take 2x cubed, no x cubed. That was the whole point of it. 7x squared minus 4x squared. 3 x squared. And we'll stop because this is the great bit. What happens now? Right, you bring it down. I would get my ruler out. Oh, look at that. That's nice. Right on the line. Plus 10x. Love it. I love it. And now you're asking yourself, all right, x, this x times what gives you this 3x squared over here? So, man, x times what gives me 3x squared? 3x. Wake up, Jeff. 3x. I know it looks scary, but it's quite nice. And now we just multiply this by 3x. So 3x times x, 3x squared. 3x times 2 is 6x. All right, we're subtracting and we know that we've done the right thing. Look, I do these sometimes in writing a test or whatever. I'm making them up. And for the life of me, I'm watching telly at the same time and I accidentally put things in the wrong spot and I have to start again. So it's fiddly, but it's quite pleasant. So 3x squared, take 3x squared, no x squared. 10x, take 6x is 4x. Yeah? We're nearly there. Oh, that was a bit, that was a bit wobbly. Oh, that's nice. Bring down the 15. And nearly there. What do I have to times x by to get 4x? Correct, 4. And, you know, I like it. My x squareds are all in line, my x's, my constants. But you haven't finished because you have to now multiply this 4 by the x plus 2. So we end up with 4x plus 8. 4x take 4x, golden because they disappear. 15 take 8 is 7. So that's why we end up with a remainder of 7. So if we look back at the example that we had, love it. That's how they did it. Oh, this is actually nicer. They've got the colour happening. This is how we can write it. Oops. Right, the 2x squared plus 3x plus 4, that's what we ended up with at the top of our doodad. And then remainder, 7 over what we divided by. Now we're going to practice this a little bit because I could divide by 3x, take 1. I could divide by x squared plus whatever, and that's when this is really your major option. However, just to show you where this is going, and I will go through this slowly in a moment, but I just want to set the scene. Remember how we did synthetic multiplication? Watch this. I was just checking if I was still recording. Okay, so pop that right at the top. If you're looking at the question that we just did, I think you can all see where the 2, the 7, the 10 and the 15 came from. 2, 7, 10, 15, yeah? Where's the minus 2 come from? Yes? It's what x equals when what? Right, when, if minus 2 was a 0. Yeah? If it was a 0, x. So if that was x take 3, then I'd be putting a positive 3 here. What if this was 2x take 1? What would I then be putting here? A half, correct. All right, so we're happy with that. Here's the new bit. We then make sure every single time you put a 0 right under that first bit. Oh, I don't know, it's a bit. Bobby just said that's a nice 0, but it's a little bit of a circle, isn't it? It's a little bit of a circle. I think, yeah, anyway, so, ready? We add. So 2 plus 0, 2. We then, am I okay, or are you writing and just tell me if you need me to stop? We then multiply. So multiply those two. Minus 2 times 2, we get minus 4. And then we add. 7 plus minus 4 is 3. And now we multiply. Minus 2 times 3 is minus 6. Add. 10 plus minus 6 is 4. Guess what we do? We multiply. We get negative 8. And we get 7. What?
We do like the white, and then the white, a little stick goes down to the white line. We thought you were doing it differently.
So go again. Put the 0. 2 plus 0 is 2. And then you multiply. Minus 2 times 2 gives you the minus 4. You add. Minus 2 times 3 is minus 6. You add. Minus 2 times 4. Sorry, Belle, you can't sort of say, I'm sort of going. Minus 2 times 4 is then the minus 8. And we add and you get 7. And you go, if you look at what we ended up with here, 2 corresponds to our 2. 3 corresponds to our 3. 4 corresponds to our 4. And lo and behold, our remainder is 7. Oh, lost that again. Kel, if my remainder wasn't 7, if it was 0, what would we say about x plus 2 or about minus 2? Kel, if instead of being 7, that was 0, what would we say about this?
We'd say,
So when you're putting it through, you have no remainder. That would make x plus 2 a factor, or it would make minus 2 a 0 / root / whatever. It's what's the other one? X-intercept. Okay? But when there's a remainder, then you cannot factorize this nicely with pull out a common factor of x plus 2. Yeah? X plus 2. We good? So as you're going through now and you're practicing, when you've got linear ones, you know, you don't even have to read what the question in the book is asking if you don't want to. You can do one and you can practice doing this, long division, and then you can double check your work with linear. Now, when it comes to a test, if it doesn't ask you to do it long division, there's no way I'm going to. As much as I love it, I'm more in love with synthetic division. Correct? As I did say though, if this is not linear up here, if we're not dividing by a linear, if we're dividing by a quadratic, then synthetic division isn't good for us. So you have to go to long division. So let's do one with a quadratic. Oh my God. What happened to my 15 minutes? Well, actually, I'll stop there so people can do and practice. So what you want to do is see that you can finish the 2C the equating coefficients, and you can start some of these questions here. Again, hello. To begin, what I suggest you do is copy this one. You've got the work solutions here if you so desire. Please notice, up here, try not to look, but that doesn't have an x cubed in it, does it? So what would we do when we pop it in? You still have to have a spot for the x cubed. So make sure you've got the 0 there. You also, there's no x, so make sure you have a spot. Otherwise, it doesn't go nicely. So you've got to have, you know, go in order. It's got to have a fourth, an x cubed, a squared, an x, and a constant. Yeah? Okay. What I will do is I'll do a couple more of these online or whatever, and then you can have a look if you get stuck. Hello. Okay, so, hello, Bob. Finn's asking, when it says perform the division, obviously this one here is asking you to practice the long division because it's giving you the example and so on. In a test, it would probably say perform the division using long division or whatever. If it doesn't say, go with whatever method you want. If I had said blah, blah, blah divided by x squared plus 3, and I just said perform the division, you would have to go long because, as we said, you can't do it with synthetic. Okay, so I guess I'll leave the dividing by the quadratics maybe for later lesson. So you've got enough. Do you have to do every single one? No. And if you're a smarty pants, as you're going through, if you double check with synthetic division as you're doing it, you're practicing that, and then you'll see you don't have to do some of the other questions when you get to it. So if we could have a go at 2D1 so that you are confident using long division. And was synthetic division quite nice? See how you go? Look, if you forget it, relax. And just, if you are doing, look at the bottom row, if you are doing synthetic division with these, what is your x value here that you put right at the start? Minus a half? 1/3? -3/2. And what I'll probably do tonight is I will do these on a video, but only check if you get stuck. Okay? Love you.